Hi there, I'm Raj Kishan Ghosh from Blenderphile, and today we will have a good look at the particle info node. So first of all, we will delete these two guys. Now this default cube will serve as our particle. So let's scale down it a bit and move it. Then we add a plane and give it a particle system. Under the particle settings, under render, we set object and then cube. Also we set its size to 1. We turn off emitter so that the emitter doesn't get rendered. Also under field weights we set the gravity to 0. And we set the normal velocity to 5. Okay. So let's now jump on to the node editor. Now we will give our cube a new material. And we go to rendered mode. Now if we press Shift A, then input, then particle info, we can see here that the particle info has some values and some vectors which can be combined to give some particle effects to the shader. Now if we add a color ramp, now first is the index. Now what this index does is each particle that is emitted is given an individual index. The first particle is given an index of 0, the next particle an index of 1, and so on. So if we put the index to the factor here and see the color ramp, we see that only one cube is black and all the rest are white. This is because the first particle is having a value of 0 and all the other particles are having a value of 1 or greater. So how we use the index? For this, we add a math node and set it to divide so that the top value, the index, will be divided by the bottom value. Now for the bottom value, we press 1000, which is the number of particles. As we see here, this is the number of particles. So if we start our animation, we see that the first particles that are created are having a color of black, and as the time progresses, the particles that are created are a white color. So this is the index. Next is the age and the lifetime. Now under particles, under emission, we can see that each particle is having a lifetime of 50. Let's change it to 250. Now this is the lifetime value that the particles get here. And the age is the number of frames that have passed after the particle has been emitted. So if we divide the age by the lifetime value, we will get a value between 0 and 1. So if the particle is just being created, it will get a value of 0, and as the time progresses, as it ages, it will gain a value of 1 and then it will be destroyed. So this effect can be used to create some flame effects, fire, etc. Here we can see that at the bottom they are getting a black color, but as they are rising up, they are getting a white color. So this is the age and lifetime. Next we will talk about the size. Now if we plug the size to the color ramp and then we see that everything turns white. Now if we go to particle settings, here we can see under physics the size. This is the size value that the particles are getting in the node. So if we change the random value from 0 to 1, we can see that the particles that are bigger, that have a size of 1, are white, and as they are getting smaller, they are getting a value of 0, which is black. So they are blended between a black and a white color. So this is the size. Next is the location. Now the location vector gives red, green and blue values corresponding to the x, y and z components of the location. So the location value is with respect to the world origin. So if world origin is here and this is the z axis, as we see here the z axis is having a color of blue. So if we press Shift A, converter and separate RGB and take only the blue output, we can see that the particles close to the origin have a gray color and the color changes to white as they go upward. So from a value of 0z to a value of 1z, there will be a blend from black to white corresponding to a value of 0 to 1, and after that there will be a white color. Similarly, the x and y components. Here red corresponds to x as we see here. So if this is the origin, then from here to here it is blending from black to white, and this is the negative x-axis. So minus values are also given a black color. So this is the location. Now we jump on to the velocity vector. Now if we separate the colors of the velocity vector and take the blue output, you can see that every particle has a color of white. Now the velocity here is corresponding to the velocity we see under the particle settings. So if we get a normal velocity of say 0.2, then they will have a color of gray as you can see here, and if we give it a value of 1, then the particles will be white. Now this is only in the z-axis because we are using a plane here which is emitting particles only in the z-axis. But suppose that we are emitting particles in all the axes. In that case, if we want to get the magnitude of the velocity, then we will use a math node. So Shift A, then converter and vector math, and we'll feed the velocity to the two inputs, and we'll also create a power node and fetch the value to the upward value. And now if we see, we don't see much difference, but if the particles are emitted in all the directions, then this will be dot product. So this vector math node and math node with dot product and power respectively will give the magnitude of the velocity which we get here. Okay. Next is the angular velocity. The velocity vector is also called linear velocity, and angular velocity is almost same like the velocity, having x, y and z values corresponding to red, green and blue colors. The difference is that the angular velocity is less related to motion along any axis and more related to the rotation of an object. So this angular velocity is not needed generally. Generally we will need the upper 6 values or vectors. The particle info node is more or less complete. Now I will discuss about the angular velocity. So if you want an idea about the angular velocity, you can keep watching. Okay, so now let's continue with some theory about the angular velocity. So first of all, we have to know that if an object is spinning in a direction, then it gets an angular velocity in a specified direction. Now, to visualize the direction of the angular velocity, if we take out our right hand in a posture of thumbs up, then if our fingers are curling in a direction, if we think that as a spinning direction, then the thumb will point in the angular velocity. So if an object has an angular velocity in positive z direction, then it will rotate as per the fingers that are curving. You can also use a bottle cap. So if we open a bottle, if the cap is rotating, it moves upwards. So if upward is its angular velocity, then it's rotating anti-clockwise as seen from top. So a spin like that means it has an angular velocity upwards. Now let's jump onto Blender. So here we see that the particles are rotating. Don't forget to turn on the dynamic or the particles will not rotate. Okay, so they are still having an angular velocity but it's not showing. So we'll check on the dynamic and we will see an angular velocity. By default it is set to velocity per hair. So the angular velocity is in the direction in which they are getting a normal velocity. So if we change the angular velocity to global x, now if the particles are having an angular velocity in this direction, then they will rotate in that direction, as you can see from curling your hands in a thumbs up position. So this is the angular velocity, and as per the spin, the objects will have different angular velocities. So the angular velocity vector will be influenced by the rotation under the particle settings. If you like this video, press like. If you want to see more of our videos, press subscribe. And if you have any suggestions, you can post them in the comments below. Visit facebook.com/blenderphile for more awesome tutorials. Hope you guys enjoyed this video and we will see you next time. Bye.